Hello, geometry students. This is a video on the warm-up and then the lesson on parallel lines. So if you look at the warm-up, we want to find a segment that is parallel to DG, so I'm going to highlight that. So segments that are parallel are lines that go in the same direction or the same plane that never intersect. So this purple line, FJ, is parallel. I'll write it as a segment. And then this red segment, EH, is also parallel to the highlighted yellow segment. For problem number 2, we want to find a segment that is perpendicular. So perpendicular, remember, means 90 degrees. So we want to find a segment that is perpendicular to GH. And in class, your students looked at that right angle, that box, and said HJ. And then for problem number 3, we want to find a skew line. In class, we discussed skew lines are lines that never intersect but are in different planes or go in different directions. So I want to find a skew line to JF. So this segment right here in red is skew, DE. It goes in a different direction. It's not in the same plane and will never intersect, JF. This green segment is also skew. It'll never intersect. So there were 2 answers here for skew. Okay, if we scroll up to problem number 4, I'm going to highlight them. So AB here and CD are parallel. Then problem number 5, we have DH highlighted there in yellow and FE in the back there. Those lines never intersect, but they are not parallel, so they are skew. And then the last question for a review of Monday's class was EF and BF. Those form a 90-degree angle, so those are perpendicular since this is a rectangular prism. Okay. In class, we skipped number 1, number 2, and number 3, so we skipped those 3 questions. And then we move to some vocabulary. So a transversal is a line that intersects 2 different lines. So in this particular problem, line L here is called the transversal. And then we talked about these vocabulary words. And just for clarity, we're going to call angles 1, angle 3, angle 6, and angle 8. Those are called exterior angles. They're on the outside. And then angles 2, angle 5, angle 4, and angle 7 are called interior angles. And then if the word corresponding, we talked about, we're, quote, in the same spot. So if we were to slide over angles 1, 2, 3, and 4, so if you can imagine cutting the piece of paper, maybe along this dotted red line, if you were to cut the paper along that dotted red line and slide over 1, 2, 3, 4, 1 would be on top of 5. They're not exactly the same. 2 would be on top of 6. 3 would be on top of 7. And 4 would be on top of 8. Again, those angles are not congruent, but if you're to slide these 4 angles to the right, so So you're going to take those 4 angles and just kind of move them over to the right. They kind of would be in the same spot. So we say angle 1 and angle 5 are corresponding. Angle 2 and angle 6 are corresponding. Angle 3 and angle 7 are corresponding. And the last pair are angle 4 and angle 8. So that's the definition of kind of corresponding angles visually. They're kind of in the same spot if you were to slide over the angles. All right. Then we have some other vocabulary words. I'm going to shrink this down a little bit. The word alternate means kind of on the other side. So here we have angle 2, and I want interior angles. So if I were to alternate along that transversal, this yellow line, and they both have to be interior, 2 and 7 are considered alternate interior angles. They cross the transversal and they're both in the inside, so they kind of jump over. The other pair is angle 4 and angle 5. This angle here and angle 5. They kind of jump over that yellow line. So those are called alternate interior angles. Okay. Then a pair of alternate exterior angles, they have to be on the outside. They have to jump over that transversal. So 1 and 8 would be considered alternate exterior. Another pair would be angle 3 and angle 6. And I'm going to mark them here kind of in green so you could see that visually. So those are alternate exterior angle pairs. Okay, moving down on our definitions. The word same side interior are 2 angles that are interior and they're on the same side of the transversal. So 4 and 7 would be a pair of same side interior. Another pair could be angle 2 and angle 3. Excuse me, angle 2 and angle 5. Those are same side interior angles. And then a new definition was same side exterior. They're on the same side of the transversal and they're both exterior. So angle 1 and angle 2 would be an example. I'm sorry, angle 1 and angle 6 would be an example. And then angle 3 and angle 8 would be the other example. So this is some of the vocabulary words related to lines. Now we already studied vertical angles and linear pairs, and there are a lot of answers here. A pair of linear angles could be, and let me just erase some of these marks. A pair of vertical angles could be angle 1 and angle 4, and remember those are congruent. Another possibility could be angle 7 and angle 6. And then linear pair are 2 angles that form a line. An example could be angle 1 and angle 2. Another example could be angle 5 and angle 7. Remember, linear pairs are supplementary and they add to 180. So moving on to our notes, just to check our vocabulary. Angle 1 here and angle 5 are called corresponding angles. Angle 6 in red and angle 4 are called alternate interior angles. Angle 2 that I marked in green and angle 7 are same side exterior angles. And then 1 and 7 are alternate exterior angles. And then we could name some other pairs, and there's other answers potentially for these, but another pair of alternate interior angles besides the one that is listed up there, angle 6 and angle 4, we could say another pair of alternate interior angles are angle 3 and angle 5. Another pair of corresponding angles, and there are lots of answers here, could be angle 2 and angle 6. And a pair of same side exterior angles, same side exterior. We already have 2 and 7, so the other pair would be angle 1 and angle 8. Right. The next thing we did in class is we talked about some of this arithmetic. So I'm going to put angle 1 is 102 degrees. You should know that angle 3 is also 102 degrees because they are vertical angles. Angle 2 is going to be 180 minus 102, and doing that on your calculator, you're going to get 78 degrees. And then because 2 and 4 are vertical, angle 4 is 78 degrees. Now, if you were to slide these angles down, and because these lines are parallel, 5 is going to be exactly the same as 1. 4 is going to be exactly the same as 8. 2 and 6 are exactly the same. And also 3 and 7 are exactly the same. And the only reason that works is because these lines are parallel, and I highlighted that yellow mark. So what do you notice? These are the notes kind of down at the bottom. I'm going to write them up here. So some of these angles are congruent. Some of these angles are supplementary. So this is at the bottom of the page, but I'm going to write it here so it's easier to write. And we have our picture with us. So if we look at the vocabulary, you should notice that the corresponding angles are always congruent. So 1 and 5, 3 and 7, 4 and 8. So corresponding angles are always congruent. If you look at 4 and 6, 3 and 5, you'll notice those are congruent. So alternate interior angles are also congruent. If you look at 1 and 7, 2 and 8, alternate exterior angles are also congruent. And then from the previous unit, we know that vertical angles are also congruent, meaning 1 and 3, 2 and 4, and so on. And then there are some pairs of angles that are supplementary. If you look at 4 and 5, the same side interior, those add up to 180. So same side interior angles are supplementary. If you look at 1 and 8 or 2 and 7, those are also supplementary. So same side exterior angles. are supplementary. And one way to remember that, supplementary starts with same or S, so does same. So they both start with S, so they are supplementary. And then from the last unit, we know that linear pairs are also supplementary. So what we just did here are actually the notes that kind of go down there at the bottom of the page. Then in class, we did two examples. Before we look at problem number 1, there is a typo in problem number 3, so I wrote that up here. So if we look at problem number 1, I'm going to label angle 4 to be 105 degrees, and then I'm going to label angle 6 to be 76 degrees. So we should know right away that vertical angles are the same. So angle 8 is 105 degrees, and angle 1 is 76 degrees because it's vertical to angle 6. To find angle 5, we could do 180 that's 105, and we'll get 75 degrees. Once you know angle 5, you know angle 3 because they are vertical. To get angle 7 here, you could do 180 minus 76. And doing that, I get 104 degrees. And since 7 is 104, we know angle 2 is 104 degrees. Then we took a look at problem number 3. I tell you that these lines are parallel in the paragraph. So it says A is parallel to B. So I'm going to mark them to be parallel. And then it says angle 5 is 82 degrees. So if angle 5 is 82, angle 6 is 82. Then angle 4 is going to be 180 minus 82 degrees because they're a linear pair, which is 98. And then we know angle 3 is also 98. Now, because these lines are parallel, if you were to cut the paper in half and slide angles 3, 4, 5, and 6 up, angle 5 is corresponding to angle 2, and it's exactly the same because the lines are parallel. Angle 6 is corresponding to angle 1, so it's also 82. And there's other ways to realize that, but if you just slide them up, 1 and 6 will be on top of each other. They're corresponding angles. Same thing with 5 and 2. And then we know that angle 4 and 7 are also equal because they're corresponding angles. Likewise, 6 and 8 are equal, or 7 and 8 are equal because they are vertical.